I created a ransomware, a malicious software that encrypts your files and makes them completely unusable unless you have a special key to decrypt them. And in this video, I'm gonna show you step by step how to do this. But before, I want you to know one thing. This is a serious stuff, a dangerous software, so I don't want you to use it with any malicious intent, or even as a joke or something. Just keep it educational purposes only and don't do anything stupid, because you can harm either your PC or someone's. Now, with that in mind, let's jump right into it. The core of ransomware, as you might have guessed, is encryption. We have two types, symmetric and asymmetric. Symmetric encryption uses one key for both encryption and decryption. It's fast and very efficient for large amounts of data, but it creates a need for secure key distribution, which might be tricky sometimes. Asymmetric encryption, on the other hand, uses a key pair, public key for encryption and private key for decryption. It's slower than symmetric, but eliminates the need of secure key distribution. Now, if you think about it, there is one issue. How do we encrypt a large amount of files very quickly and yet make it impossible for our victim to decrypt them? Ladies and gentlemen, introducing hybrid encryption. Symmetric encryption is very fast, so it will be used to encrypt files. When finished, we will encrypt the symmetric key with hard-coded public key. Now the only way to get the files back is to have a private key that sits safely on an attacker's computer. And now when you know the idea, we are ready to start talking about the code. First we need to declare a few variables. First one will hold a path to our root directory, so basically everything beneath it will get encrypted. Second one will hold a path to public.txt, which is a text file that contains public key that we'll use for RSA encryption. And the last one holds the encrypted AES key, so this is like a final product of our script. Then we generate the symmetric key, or AES key, and this function generate key does that. So it's rather simple. First we get a char set, which is a set of characters that can and will most likely all of them appear in our key. The key size is specified here, string length 256. We create a buffer that will hold a key. It's of string length +1 times size of a character. And here a for loop takes care of writing to this buffer. So we are randomly choosing one character from the char set and writing it to the buffer 256 times. And the last thing, of course, we are returning the key and store it in key variable right here. Next thing, we call encrypt directory with a path and a key. This directory also, sorry, not this one, where is it? Here. It's also rather simple, because if you think about it, under the root directory, the danger one, we can spot two things. We can spot files and we can spot other directories. So what we need to do is to, if we see a file, encrypt it, and if we see a directory, go inside and repeat the process. So encrypt everything, go inside another folder if it exists, encrypt everything, go inside another folder if it exists, and so on and so on. So, as you may have guessed, encrypt directory is a recursive function. It uses a Dirent library, which I will link in the description. All you have to do is to basically create a new item here, add new item, call it dirent.h, copy paste what I will link you in the description, so this code, and remember to include it here at the top. Once you do that, you can browse the directories. So as you can see, if it spots, it opens the directory, and if it spots another directory, it calls itself, and if it spots a file, it calls encrypt file function with file path and key arguments that we will talk about it right now. Okay, we start by creating a handle to a file that we'll be encrypting with create file a function. What you need to know about it is that the create verb is a little misleading, if you ask me. Like, you can both create a file with this function and open an existing file. So let me show you what I mean, because as a first parameter, we pass a path to a file. Then we specify access type, so we want to both read and write to this function. Next parameter is, I don't remember what is this, it's what it's called, but it basically 0 here means that none other program can access this file while we are accessing it. So during the work of our script, of our ransomware, no other process can mess with our file. Let me put it this way. Here you just pass no, that's not important for us. And now, this one, 1, 2, 3, 4, fifth parameter. Here we specify, either we want to, because we can create file, we can append it to a file, we can just open a file, we can do multiple things. And we want to open an existing file, so we specify open existing. That's why I'm saying that it is kinda misleading, because here we say create, here we say that we are not creating, but we are opening a file. If you wanted to create a file, and here you would put an option, actually let me show you, because there is a, I'm sure you are already familiar with this documentation. If you are not, please familiarize yourself, because it is super handy while working with Windows API. Crypt, no, not crypt, create file, sorry. Create file a function. Here, okay. So this is parameter called DW creation disposition. And you can read about it here. Here. An action to take on a file or device that exists or does not exist. And you have multiple options. We picked, of course, open existing because we know that this file exists and we want to encrypt it. So this is obvious for us, but you have like 5 different options. Yes. And the last, okay, not last. Next we have, let me stick to the documentation, DW flags and attributes. The file or device attributes and flags, file attribute normal being the most common default value for this file, and let it we can leave it at default. So you just pass this file attribute normal, and the last parameter is about sorry, and the last parameter is about templates, because apparently you can work with some templates. I'm not familiar with it. I've never done that. But yeah, if you don't need this, just pass null here. And okay, so once we have a handle to a file and we can actually do something with it, let's initialize a crypt provider. So a crypt provider is a part of WinCrypt.h library that you also need to include at the top of your of the code. And crypt provider is a software module that actually performs our encryption. So we initialize it by plugging it with an algorithm that we want it to work with. So with crypt acquire context, you, as a first argument, you pass a pointer to your provider like this. You pass an algorithms that you pass an algorithms that you will want to work with, and yeah, this is basically in short how it works. I can also show you a documentation part. A crypt acquire context function is used to acquire a handle to a particular key container within a particular CSP, so cryptographic service provider. And yeah, this returns handle, blah, blah, blah. That's not important for us. Okay, so think about it as just initiating the crypt provider with a certain algorithm. Okay, once we do that, we want to somehow plug our key to this provider so that it can use it to encrypt the file. And we do this by chaining those three functions. And actually, let me start with crypt derived key. And this function generates cryptographic session key derived from the base data value. And this, okay, let me actually continue reading. This function is the same as cryptgen. Okay, not this. We want, yeah, here as a one of parameters, because if you look at the crypt derived key, of course you plug the provider, you plug the algorithm of a key, which is AES. You plug a hash object, 0 here, and a pointer to a key handle. Now, this hash object is a little tricky, because you would think that this crypt derived key, okay, you put your key here, and this just connects your key to the crypt provider. And that's not really this straightforward, because it expects us to provide a hash object. As you can see, a handle to a hash object that has been fed the exact base data. To obtain this handle, an application must first create a hash object with crypt create hash. Let me open this page, and then add the base data, which is our AES key data, to the hash object with crypt hash data. Okay, this process is described in detail on this page. And as we can see, before we call crypt derived key, we do call crypt create hash and crypt hash data. Now, this is not opening for some reason. Crypt create hash. Okay. Crypt create hash function initiates the hashing of a stream of data. So again, we initiate the hashing with of our key. We create a handle to this hash object, and with create hash function, as you can see as parameters, we put the crypt provider handle, the algorithm of a hash, and the pointer to a hash to hash object handle. Now, if you want to know, let me go to the crypt hash data. Crypt hash data function adds data to a specified hash object. So it is a little confusing, but let me go through this one more time. We create a hash object that with a certain algorithm. Then we add our key to this hash object, and it's being hashed here. And we plug this hash object to crypt derived key, and crypt derived key lets us use our key while encrypting file afterwards. Now I hope this is clear. And of course, like, parameters here are pretty straightforward. It's just, a handle to our hash object, key and length of a key. And the last parameter we are not using. Okay, so I hope the process of importing a key is clear. And as the almost last thing in encrypt file function is the encryption itself. So we get the size of our file, and we need to determine what size will this file have after encrypting. Because, you know, if you encrypt a file, it changes its size. And if you are reading from a file, and if you want to write a stream of bytes to the same file, and it's larger than the original file, we have conflict here. So we first need to determine the size after encryption. We do that with encrypt function, and by specifying a null here. As you can see in the documentation of encrypt function, the not the hash, sorry, the PB data parameter, which is 1, 2, 3, 4, fifth parameter. This one? Wait, 1, 2, 3, 4, 5. Yes, okay. I can count. The fifth parameter, if it's null, this function will calculate the required size for this ciphertext and place that in the value pointed by PDW data length parameter, which is the next one, which is this. Okay, so once we know how much data we require for encrypted file, we can create a new buffer for it to hold the encrypted text, or to hold the encrypted bytes basically in this new buffer. So we read, so once we create this buffer, we read data from our file to the buffer. Of course, this buffer will be too large for this data, but that's good. And then we script encrypt one more time, but this time we are putting a pointer to our buffer here instead of null, and this encrypt then will encrypt our buffer. Okay, a lot of crypt word here. And yeah, once we do that, you can see we are printing successfully encrypted the buffer, and we are I'm sorry, writing the buffer back to the file. Right. So that's how encrypt file function works. And as you remember, we are doing this for every file we find. But that's not the end, because next and the last thing is to encrypt the actual AES key with a public.txt, with a public key that sits inside public.txt. And this is done by encrypt AES function. So let me show you how this works. One more thing before we move on to the next function, I forgot to tell you how to get the RSA keeper. So go to this website, cryptotools.net. As you might expect, there are many ways to generate RSA key, but I just use an online generator just to make it simple. So pick a length of 4096. Basically, the bigger the key, the more data you can encrypt with it. So that we don't have any trouble encrypting our AES key, choose the biggest size you can. And so you can see a couple of seconds, and we have a private key and a public key here. So just copy and paste them to their corresponding directories, to their corresponding files. The main problem with the encrypt AES function will be to understand how we import a public key. Like, this is the core difference, let's put it this way, because as you can see, first what we do is to just read a public key from a file. So it's again the same process: create file function, getting a file size, allocating some space, reading the file to a buffer, and here we are just printing it on the screen so that we are sure it worked. But what comes now is to actually, because we need to import a public key to the provider. Same thing, crypt acquire context, as you remember. And the function that does that is called crypt import public key info. Obvious name, import public key info. Everything is everything is obvious. The problem is that it requires. Let me show you. The problem is that it requires. Where is it? This third parameter. It requires a pcert public key info structure. Yes, and we need to get it somehow. And this is definitely not just this is not just a string of text, as we have our public key right now in the code. So we need to convert it in a bunch of ways. And after searching the internet, I found a post from Stack Overflow, asked on 2009, so that's a long time ago. And apparently this guy had the same problem that I had, that he didn't know how to do it. And Mr. Rimono came with the answer 1 year later. And he said that he discovered the magic sequence of calls to import the RSA public key in PEM format. This is what we have. Here you go. So you can see here's another chain of functions. Crypt string to binary first, crypt decode object ex, and we call it twice with different parameters. And then we have our desired structure. Now here I have my comments to it. So first we calculate size of the converted server public key, and then we convert and save server public key to the buffer. I'm calling it a server public key. Actually, this is because this code is simplified for the purpose of the video. There are flaws in it that would make it work less. Would make it does work, but the real world ransomware, they have a lot of other functionalities that this code lacks. I'm gonna talk about it at the end, but yeah, you don't need those functionalities. This is just for educational purposes, of course, so don't worry. And yeah, once we convert the once we are done with the first conversion with crypt string to binary, we want to create this third public key infrastructure. And we are doing this with crypt decode object ex. So we are declaring a structure, creating a variable that will hold a public key info length, and we call this function with those parameters. I don't really want to read further documentation on the video, because it would just make it unnecessarily longer, but you are welcome to read it by yourself and make sure you understand it. And this, I will link you this all of these functions in the description, so it's easy for you to access it. Now, after we convert it, we acquire context. Here we can use crypt import public key function to actually import our key in desired encoding to the imported to the server public key crypt provider. And here is a handle to the key. Now the rest of the code is very similar. We calculate the size of the key after encrypting. We encrypt it. we encrypt it, and we create a file. Oh, now you can see. Now we don't because we have when we were encrypting a file, this file existed, so we had a path to it, and we wanted to open it using create file a function. Right now we have but with AES key, we have AES don't delete, like this is our path to a file that does not exist yet. So we are calling the same function, but with a create new value for this parameter. This is very important. Everything else is pretty much the same. And once you do that, you can write to the newly created file, and that's the end. Yeah, files are encrypted now. So let me show you how this actually works. So as you can see, here's a danger folder. It has a bunch of images from other videos, and inside the folder, so we can test this functionality. As you can see, all of those files are accessible. Now as you launch it, launch the ransomware, a file appears on the desktop, because this is a fixed destination, so you can of course change it, and it contains some gibberish, which is our encrypted AES key. And if you try to check your files, they are completely inaccessible. You can't open any images, even in the folder inside. All the images are encrypted, and the text file is again some gibberish. So you know it works. And now as we have our files encrypted, let's try to decrypt them. So let me show you how the decryptor code looks like. As you can see, the decryptor code looks very similar, but in reverse. Like, we have the same path variable, we have a key, but this is a private key, not a public key. We have AES don't delete, and we also have, just for debugging purposes, a decrypted AES key being written to a file. Okay, as you can see, first what we need to do is to decrypt our AES with the decrypt AES function, which is very similar to encrypt AES function naturally, because we are first reading a key from a file, printing it just for debugging. As you can see, I even didn't, when I was copy pasting this, I didn't change the variable names. But yeah, whatever. Now, this part is a little different because if you look at the RSA key pair, a public key is a part of a private key. So when we were importing to the CSP, to the cryptographic service provider, when we were importing a public key, we were using a function called crypt import public key info, if I recall correctly. Here, we are gonna be using crypt import key, because we are importing the whole key, not only the public key part of it. Like, you can literally take those two keys when you let's say in this generator website that I showed you, and compare it to each other. You will see that the first part of a private key is exactly what's in a public key. Yeah, so pretty much the only difference here is that we are using crypt and import key, and we don't need to we don't need to use this. Let me show you. We don't need the structure, which is called third public key info, of course, because it's for public key info. We just need we can just allocate. We can just keep our private key blob as a byte. Yeah, because this function expects us to expects this kind of input. Okay, so I can actually zoom out a little bit so you can see how the whole importing key process looks here. And after you import a private key, we are ready to decrypt AES key. So we have to first read from the AES.delete file. We allocate AES key in a buffer. We save it in a buffer. Then we use crypt decrypt function that decrypts AES key, and we save it. Here we actually save AES key, like the decrypted AES key, to a buffer, to a new file. I'm sorry, but you don't need to do that. You can just return the buffer with encrypted AES. So once that's done, what you will get from this output is not the AES key by itself. Actually, that's a good way to visualize it is to actually run this code. And once you run it, I can show you that everything is decrypted back to its original form. And the AES decrypted file shows us this. First 256 characters, I believe it ends somewhere there, is our AES key. The rest is some gibberish that we have to cut out. Okay, you can see this is the encrypted version, and this is the decrypted version. Okay, so as we know the size of a key itself, we can easily separate it like this from the rest and save it in decrypted AES variable. Okay, so once we have this, it's just so once we have this, it's just a matter of going through each file, literally the same function, and decrypt it. Create file A, same thing. We are initiating another cryptographic service provider. We are importing our key, and now instead of crypt encrypt, again we are calling crypt decrypt. I think this is pretty understandable. And just remember that at the end of each function like this, it's a good practice to clean after yourself. So free all the buffers that you won't be using anymore, and close the handles and stuff like this. Okay, so I think that's it. Actually, okay, no, one more thing, because you might be wondering what is this display error message function. It's present in both codes and I didn't mention it. It's just something that I copied from the internet, and it allows me to get the error message from getLastError instead of just the error code. Because you might know the getLastError function. Let me show you. GetLastError function. GetLastError. Like this. GetLastError prints you last error, right? And it actually prints you a system error code, one of those. For example, I don't know, let's put a random one. For example, code 84. So when you just print system error code, when you just print the output of getLastError, you will get, for example, value 85. But if you call the display error message function and put getLastError as a parameter here, you will get straight up this message. So that's just convenient to do that, so you don't have to look for each error code separately. You just have it as an output. But everything you will have everything in my GitHub repository, link in the description, and I think we can wrap it up. One more thing before we finish. This approach, although it's fine, has some flaws, and one of them is that AES encryption is way easier to brute force than RSA encryption. Therefore, if I were to get hit with this ransomware, it would be a good idea to try to break AES encryption on the file and get AES key this way. And if I get AES key, I can encrypt every other file. Now, a really simple solution to this would be to implement file encryption like this. While encrypting files, we generate unique AES key for each file and then encrypt each AES key with RSA public key, so that the victim would have to brute force hundreds of files separately. The other issue with this approach is that we can't really successfully attack multiple systems. Because if someone were to receive a private key to decrypt their files, he would then send it to other victims so they can decrypt their files for free without paying the ransom if you were to use it like this. Now, the solution, the simplest solution, would be to generate a unique keeper for each encryption. Let me show you. Once we spread malware to multiple victims, we would generate a unique pair of keys for each encrypted device, perform encryption like usual, but using newly generated keys, and at the end, encrypt client RSA private key with server RSA public key. Complete scheme looks like this. With these modifications applied, I think it would be a decent piece of malware. But once again, I want to warn you that even though you're welcome to upgrade it and experiment with it, do it only on your system, only for educational purposes. Don't do anything illegal or stupid. Thanks for sticking till the end, and if you liked it, please leave a thumbs up and subscribe so you don't miss any new content. And if you didn't like it, please leave a comment and tell me what you would change, what I could do better to make better videos. But anyway, see you soon.